Hey YouTube, XCT here. Today we are going to use the cached Kerberos ticket we found on client 02 to move to client 03. After some host enumeration and exploring Windows Defender application control, we come up with a plan to exploit yet another user and move to his client machine. Alright, let's get started. So we are on client 02 again, and if we look at the temp directory here, we can see that there's a cached Kerberos ticket from Connor Brown. How does this ticket end up here? Well, if a domain user connects to a Linux machine, basically Kerberos is used and the ticket for the user is cached in temp. It's not readable by everyone, but we are root, so we can access it. So what we want to do is basically take this ticket, copy it to our machine, and then see if we can use it. So let's do that. Just like this. And now we do an export like this and klist. And now we can see that the ticket is properly loaded, right? In order for this to work, you also need to adjust this config file here, krv5.conf, and it should look somewhat like this. Basically, you just need to adjust it for the domain that you are using. Okay, so how do we know where this user has permissions? Well, for once, we could check Bloodhound. But in this case, it's not going to show it because this user actually just has local group permissions and Bloodhound sometimes misses these. So what other options do we have? We could basically try to spray credentials via crackmap.exec, like spray the ticket. But at least I couldn't get this to work because it only works if you like specify the full host name and you can't specify a range of IPs. So I don't really know how to do that. Except if we were to like make a full list of host names like client02.shinra-dev.vl and so on. That might work. But there's also an easier way because we know already that Connor is connecting to this machine. So somehow in the logs we should probably see where he is coming from. So let's just do a tail on the off log here. And we can see Carol Mason here, but also Connor Brown. Let's maybe just do less here. Now we can see a bit more, and you can see that Connor Brown is actually coming from this IP here. So we know this is probably the client of Connor Brown, right? Doesn't really mean we are able to connect as the user to this machine, but sometimes users are like local admins or have permissions on their own machines, right? So it's a reasonable assumption that we might be able to connect to this machine as Connor. See if it really is up. Doesn't seem to accept pings, but that doesn't really mean anything, right? Okay, so how are we going to connect there? First of all, let's see if winrm might be open on the machine. And we can see it is indeed open. So maybe there's a chance this user can actually connect via winrm. So let's try that. And we're going to do that like this. Proxy chains, of course, because we are not directly in the network. Then winrm has a -r option where you specify the realm, and it basically is trying to use Kerberos. And we can see that this worked. We got to connect to the machine via winrm. Let's see what kind of permissions this user has. And he is indeed, like we assumed, an admin on his local machine. So we probably could have used something else to connect as well, something like psexec or so, but winrm just works fine here. All right, so the first thing we really want to do is we want to get a sliver beacon again, because now we are back in the Windows world and having beacons everywhere would really help us out, right? Let's first of all generate one. So we go here to Sliver and to generate beacon, give it our IP, format shellcode, and then I'm just storing it in the location I'm using for this lab, right? The -G here is to disable shikataganai because I don't want to use that. All right, then we also have to start the listener if you don't have it anymore. Oh, typo. And TLS, of course. And then if you go to jobs, you can see it's listening and everything looks kind of nice. So the other thing I'm doing but not showing here is basically this is the generated shellcode from Sliver. and I'm encoding it into a PNG file, and it's also encrypted. So basically it's just a PNG, and at the end of the PNG there's like a separator, and then there's the shellcode, and the shellcode is encrypted. That's just something I need for my beacon. It's nothing special, but it helps a bit to like make your shellcode a bit more stealthy, right? Okay. And also, like, it's a normal PNG, it's not broken, right? You can just view it. It's a picture of errors. So yeah. And then we have basically everything we need. So first of all, let's just put it here and see if that works. And then I called it Spotify.exe. So let's put that here. All right. And then we're just going to run it and see if we actually get the request and so on, right? So here we can see that we actually get the request for Spotify, that's our download, but we don't get the request for the shellcode. So something must be wrong. And here we get the error message now. Your organization used a device guard to block this app. Contact your support person for more information. So this is new. We haven't seen that before. This is also different from App Locker, and this is basically where Windows Defender application control is finally becoming a problem for us. And you can also see that like winrm died here. For some reason it's always doing that for me, even like on a completely new VM. This only happens when I use Kerberos, so I don't know, maybe it's some bug in winrm. It's not too bad, you can just reconnect, right? But it's a bit annoying because it happens a lot. But yeah, let's focus on Windows Defender application control and see if we can somehow get around it. All right, so we somehow have to find out what the policy of WDAC is, right? If we know the policy, we might be able to find some way to get around it. Also, we are system, so maybe this would also help to do something. Okay, there's nothing on desktop. Maybe in administrator. Let's just check that quickly. There's the flag, but other than that, oh, look at documents. This is interesting. So let's go to documents. This looks like the admin, the local admin, actually created the WDAC policy, and he left the compiled file here. So this is some kind of binary, but he also left the XML here. So let's have a look at that one. And it crashed again. I'm sorry for that. All right, here we have the XML. Let me scroll to the top here. Let's just scroll a bit and see if there's anything interesting here. File rules, so this is interesting. Basically, this XML file is full of rules because if you use the Windows Defender application control wizard, you get a really good set of default rules that are pretty tight, but administrators still need to make sure that the software that the company is actually using is also being able to run, right? So it doesn't really make sense to block everything because the company obviously needs applications to do its job. So they usually add some extra rules, some exceptions. And you can see two of them here. One of them is that the program files folder is actually exempt from WDAC. And the same is true for the system32 folder. So these are already like two locations where we could try to place our beacon. And the rest, it's all deny rules, right? These two are allow and the rest is deny here. And here at the very end, you can also see that this was basically created with the WDAC wizard with the signed and reputable rules. And these basically what the name implies is that you need either a signed application, either by Microsoft or by a reputable vendor, something that's considered trusted. So we don't really have to play with signatures at this point, but it's good to know. But yeah, what we saw is that there are basically two locations where we could try to place our payload. All right, let's go to Windows System 32 here. And then let's just get the file again. And technically we should be able to execute it from here. So let's see if it's actually doing something. You can see we got some output, so it actually ran, right? And we can also see it got our PNG file from here. Let's go to Sliver here and we can see that our beacon is actually alive. So let's use that one. And then it's just do an ls to see that it works. Yeah, and you can see that we get a directory listing of system32 here. So we managed to get our beacon onto the system and basically bypass WDAC. Admittedly, it's not a very exciting bypass. We just looked at the rules and found one location that we can use. But on the next box, we will see that this can also be a bit more tight and more difficult to bypass. So one other thing to consider is, let's say we don't know these rules. We can still basically bypass this in this case, because if we go to code integrity here in system32, this is basically where the WDAC rules are stored. And if we go to CI policies and to active, you can see the active rule basically here. And there are two ways to deploy this basically. You can do this via GPO or you can deploy it locally. And a local deployment basically just means that you generate this CIP file and copy it into this folder. And since we are administrator, in this case, we can just remove the file and reboot the machine and all the WDAC rules will be disabled. This doesn't really work if it's GPO deployed, only if you do like the local deployment. Yeah, but just FYI, if you ever like find this locally deployed, you can just move it out of the way if you want to. So just to sum up the topic a bit, basically Windows Defender Application Control and AppLogger are very similar. They solve, or they try to solve the same problem, basically preventing a non-privileged user from, or even an admin in some cases, from running applications that are untrusted. And AppLogger was like the old way to do it, and it has a lot of like feature overlap with WDAC, but WDAC is just the newer and more robust version. And actually, AppLogger isn't considered a security boundary, while WDAC is. So this is like the new hot thing that you will probably encounter. Maybe older organization, you will rather find AppLogger, but this is something that will come more and more. It's also a bit harder to bypass. And also, if you just have this binary form of the rules, you can basically use the script here by manifestation, which allows you to recover the XML from the binary form. So you basically just give it the binary file and you can convert it back to XML and then read the rules. That's at least the idea. I found that this doesn't work with the latest version of the WDAC wizard rules. For some kind of reason, it can't really pass them. But this is one way to do it if you have like the old format, I think. All right, let's actually get an interactive beacon again here, just for the sake of the video, because, you know, we don't have the time to wait a minute for every command. All right, so let's do some enumeration. First of all, let's just do an ls on C here, and we can see there's an unusual folder here called local workspace. So let's explore that one. And there is an IPynb file. So what are these kind of files? These are Jupyter Notebook playbooks. So Jupyter Notebooks essentially just are a way to run Python code, but it's making it in like a nice visual way. And here we can like see the online demo, right? You have basically these files that intermix Markdown with Python code. So you can like write nice stuff here, then have some Python code here executed. The Python code is generating a graph. It's directly displayed here. So this is like a very common thing if you are into data science or something like that. And apparently this user is using these files. It's a bit suspicious that it says local workspace. Maybe there's also a remote workspace. And if you remember, like from the very first video, that actually there was a share, but we didn't really know what it was for at this point. And with get SMB mapping, we can see that there's actually a share mounted here. It's assigned the Z letter, and it's mounted from client 04. Remember, we are on client 03, right? So there's a shared workspace between these two workstations, and somehow these are using IPynb files. You could think at this point, maybe just like put Python code there, right? And hope the other one runs it. And I guess that's a reasonable assumption. But in this case, the other user is smart enough to not just run a playbook you put there. So you have to like look for actually some other way to exploit it that's automatically triggered whenever an IPyNB file, a Jupyter notebook file is opened, right? So let's do some more enumeration. Maybe we can find the kind of software that is used to actually open these notebooks. And in program files, let's see, there's Microsoft Visual Studio Code. This is pretty interesting because apparently Visual Studio Code is able to open Jupyter notebooks. So let's see if there's maybe like a CVE or something like that. And yeah, there seems to be something here. Also this one. So let's just check them out. There seems to be, let's see, arbitrary code execution when a user views these malicious files. This is something we want, right? Ideally, we just want the user to view the file and then execute code somehow. Let's see if there's an exploit somehow here. No, there's no exploit here. Maybe we have more luck with this post. This is indeed the case. This post is a lot better and details like how to exploit the issue. Basically, there was a cross-site scripting vulnerability in these files because you can do Markdown and you can use HTML here in the Markdown, and this was the vulnerability, right? You could use the on arrow just like you would do any other XSS vulnerability. So while he is basically describing how to get RCE, it's pretty hard to get this working in the environment. You can try it, and I'm sure it works somehow, but it's not trivial. So if you just go to the top here, you can see that he references another post that just uses the XSS for an arbitrary file read. And maybe this is enough. Let's just see. We need a specific version of Visual Studio here. And then it's suggesting to read past WD or an SSH key. So maybe that's an option. We have to check though, like what kind of operating system client O4 is, right? Maybe it's not a Linux box, then obviously this doesn't make sense. Let's see if there's a POC actually here. Yeah, there's actually a POC here that, let's see how it does it. It does the XSS. Okay, and then just using fetch, which is like an XML HTTP request. And it's using that to read the local file. And then it's probably sending it back. Let's see. It's also grabbing an SSH key here. Okay, yeah, and then it's basically sending the result to an endpoint, right? So if we modify the payload a bit, we should be able to read a local file and send it back to our machine if we basically place a malicious Jupyter notebook file on this share. So that's the basic idea that we're going to follow and hope that we can maybe read some interesting local files. All right, let's say we were able to like craft a Jupyter notebook file that exfiltrates a local file. We still don't know what kind of file, right? And we don't even know the operating system of the target, so that's a problem. So first of all, this is the shell on Web01 where we spawn a SOX proxy, right? If we just ping the IP of the machine, we can already see it's TTL 128. So this is likely a Windows machine. And we also want to know like if it has something like SSH open, because then like getting a key is back on the menu, right? So let's just do, and we can see that SSH is indeed open. So now we know it's a Windows machine. It has SSH open, but we don't know the username, right? On Linux, you can just LFI the etc passwd, but on Windows, that's not possible. So we have to find some other way to get the username. And one way we can do that is, first of all, let's connect to the share, right? We already know the share from the beginning, and we can just use the William Davis user we had like from the very start when we enumerated, right? And then just see what kind of shares exist. Let's do shares, go to workspace. No, I think it's use workspace. Yes. All right, we saw this share like in the beginning. But now we know we have to place a Jupyter notebook file here to proceed. But we still don't know the username, as I said. So one way you can approach this is by basically putting a file here that would send back a hash to us whenever a normal user is just opening this share in his Explorer, right? These hash grabbing payloads like SCF files, INI files, LNK files, something like that. And basically one way to do that is with a tool I've written, which is hashgrab. I'm going to use that one. If we do it like this basically generates a couple of files for us. SCF, URL, library MS, desktop, yeah, you can see lots of different file formats, right? So now we can just put them there. So let's do it like this. And then when the user that's using this workspace is opening this in Explorer, we might get a hash. And I have an SMB server running here, so as soon as this happens, we might be able to see a hash here, right? You could also use like Responder, but I prefer to use that one now. Okay, so let's put that there. Also the URL and see if we can get a hash. And yeah, we already got one. That was lucky, pretty fast. And now we can see that the user opening this share is paula.perry. We can try to crack the hash. I won't do it because I know it doesn't crack, but definitely makes sense to try it. The big thing we got here though is the username. So now we know how to craft the LFI, so we can try to get the key of Paula Perry. Of course, we don't really know if she has a key, but we're just going to try, right? All right, let's now look at the payload itself. This is basically just from the thing I showed you before, copy pasted and a bit cleaned up. We have to tell it here which file to fetch basically, right? So we can do users paula.perry and then try to get a key like this. We don't know it's an RSA key or anything like this. It's just like trying it out, right? Could also be an elliptic curve key or something like that. Okay, so we're reading this file in the SSH folder, and then we're just going to send it back to our machine as a string. So let's see if this actually works. We can just reconnect to the share, just like we did before. Use workspace, and then we put whip.ipynb. All right. And now we just wait and see if it works. And if it doesn't, we adjust the payload and try again. And we get a hit here. This is actually the private key, so RSA was correct. Let's just take this here, maybe from like here to here. And then we can put it in CyberChef and URL decode it. It's not perfect though. You can see like removing the URL decoding also like removes the plus that was probably here, right? Plus is a space. Also, we still have /ns in here, so it's not ideal. Let's just try to replace the /ns here. This looks better, but it's not perfect yet. I think, yes, we still have like spaces in here. So let's now do a replace and just go for the spaces and replace them with a plus. And now it looks pretty good, I think, except here in the header, right? So we still have a bit of cleanup here. So now we got it here. Let's just place this here and here. And I think it should be pretty okay. Let's just try. Gotta fix the permissions. And yeah, this actually worked. We got to connect as Paula Perry to client 04. Let's do a quick check on the permissions here. But yeah, this is just a normal low privileged user, so we probably have to look for a privisk. Alright, that's it for this video. So in the next one, we are going to move more to Active Directory attacks and also like probably for the rest of the whole series. So the client attacks are over and now we are going to Active Directory land. I hope you enjoyed this video and Thank you for watching. See you next time.